For surfacing, how many of you guys have experience with surfacing?
In SolidWorks.
How many of you have never used surfacing in SolidWorks? Okay.
Okay.
So there's a little bit of a blend here. So I'm going to start out again a little bit slower on surfacing. We're just going to talk briefly on the basics and some theory here of surfacing. So let's say I want to make a cylinder, and I'm not using surfacing yet. I'm just doing my normal workflow. So I can make my circle, my cylinder, and it's going to be 100 millimeters OD and some length. Let's just say 100 as well. Okay, that's my cylinder using solid modeling techniques. Or if you haven't used surfacing before, then you just say the normal way. But if I want to make this with surfacing, then what I can do is if I just go over to a fresh part here, I can still start out with the same circular sketch. So I can make my circle, it's 100 millimeters. And then rather than doing my extruded boss, I'm using the extruded surface command. And when I do this, the extruded surface command works very similarly to the extruded boss command. So a lot of the settings are going to look familiar. Oh, shoot. In astronomy, that would be close enough. Okay. So after I extrude that surface, then it basically just looks like a little tube. It's a little bit hard to see on the projection here, but the edges of the surface, and I can't highlight it because then it changes the color. But if you look at the circular edges at the top and the bottom of my tube, they're going to show up in blue. That indicates an open edge. So basically, this is the big deal with surfacing SolidWorks. In SolidWorks, with a standard solid model, your edges have two faces attached to them. So if I go back to my first cylinder here, this circular edge at the top, here's a face, here's a second face. Circular edge at the bottom, here's a face, here's a second face. So in solid modeling, your edges are connecting two faces together. In surface modeling, your edges can connect one or two faces. One or two. There's no other number there. So it's one or two. In a solid, it's always two. And to finish making the cylinder, I just have to close off these ends here. So let's say I want to cap off the top. So I throw another surface on there. Cap off the bottom. Throw another surface on there. You might be looking at those edges and seeing they're still blue and wondering what's going on, right? So there's an edge there. Here's a face, here's a second face. So why are they still blue? Why are they still showing up as open? The reason here is these are all separate solid bodies. So if I hide the middle one, it's a lot more apparent. So I basically have a body here with an edge and a single face, body here with an edge and a single face. And if I reverse it, go back to my first tube, we have the same thing here. So they're all still open edges. So what I need to do is basically take these surfaces, so similar to how we can use the combine tool to take solids and turn them into one single solid. I can also combine surfaces into a single surface. So if I take all of them here, the command's called knit surface. It basically takes surfaces, turns them into one. Then those edges now show up in black. And for those of you who are new to surfacing, this is going to be a trap that you want to be watching out for. Right now, this cylinder and the previous cylinder, if you ignore the feature manager tree, are visually indistinguishable. They look exactly the same. They have two black edges. They have three faces, but this is still technically a surface. So in the tree, they'll say surface bodies one. So just like you have your solid bodies folder, you have a surface bodies folder. So the last step I need to do here is I can basically add material to it and just turn this back into a solid. So now at this point in the tree, it shows up as solid body one, but visually it's indistinguishable. So if I go before that thicken command and after the thicken command, it's the same thing. And at this point, these are now identical cylinders. They're the same size. They're going to have the same mass. I could use them for whatever model I want. So this is kind of starting to beg the question, what's the purpose of surfacing? Why would I model like this? And the quick answer is, if you're going to make a cylinder, do not use surfacing. This is probably the worst application of surfacing possible, but it kind of just shows us why you might want to use surfacing sometimes. Under the hood, SolidWorks solid modeling is based off of surfaces. So when you're running command and it fails for some reason, you may be able to get around that failure. Let's say you can't go back in the tree and fix whatever is causing it. You can get around that by using surfacing. So rather than making the whole cylinder in one single command, I can break it out into basically 5 separate commands and dive in a little bit deeper and see where that error might be happening and how I can address it, how I can fix it, how I can get around it. So surfacing is letting us go under the hood of SolidWorks and build our geometry face by face. So the trade-off there is it's a lot of work and it's a lot slower than solid modeling. But for some geometries, it will require you to use surfacing to get the shape you want. Or if you have maybe like some kind of imported geometry, so if you have a step file that's being brought in, you need to modify it, then you're not going to have a feature manager tree that you can go back in and modify a dimension or suppress a feature. So in that vein of thinking, one of the surfacing commands I want to show is a filled surface. And just with the amount of time we have, I'm not going to try to turn this into a surfacing class because no one would like that. It's going to be way too much content for how much time we have. But I just want to kind of highlight some of the features of surfacing. And then also, if you are kind of someone who wants to teach yourself rather than take a class, some of the commands that you can kind of prioritize or at least see what they can do. That way you can pick and choose what you want to learn and what you don't want to learn first. So with filled surface, this is kind of one of the bread and butter tools of surfacing, especially for repairing geometry or dealing with imported geometry. What you can do is if you have a hole in your model, you basically tell it, here's the hole inside the model. You click on all the edges. And then based off of the edges of that hole that define the boundary, what it'll do is it'll create a surface for you. And then we can also specify how that surface attaches to the adjoining surface or adjoining surfaces, plural. So I can make it contact, I can make it tangent, curvature continuous. So I have all these different options here. Depending on what type of patch you're trying to make, not all of these options will work. The analogy I like to use here is if you have like a rug in your room and you scoot your couch back and it just pushes the rug up and you have a little mound in the middle of your living room. A similar thing is happening with surfaces, but with less rugs and more math. Basically, when I move from contact to tangent to curvature, I would imagine I'm just pushing on the edges of the rug harder and harder. They're basically creating more and more constraints on that surface. And if I push it too far, and it actually is fine here because it's a relatively simple geometry. If I push it too far, it's not able to calculate the surface necessary to join all those edges with that curvature constraint or with that tangent constraint. And usually it'll just disappear your preview. So when the preview disappears, usually your feature is going to fail. Sometimes I'll just Hail Mary it and I'll just click on OK and it'll actually build anyways. Most of the time, once the preview disappears, you're done. And you have to go back down to tangent or go back down to contact. So we can basically fill that in and it'll just patch our surface for us. And in a vacuum like this, it's hard to maybe think about why this is useful. But if I imagine this is part of my imported model and I just have bad geometry in a section of my model, I can basically slice it out and then replace it with a patch. So if let's see here, there we go. So let's say there's some kind of defect right here in the middle of my model or the middle of this face. What I did here is I basically just made a sketch around that section. You can use whatever type of sketch you want. I did some splines here just to make the edges a little bit more curvy so you can see what's going on, but you could do a square or a rectangle, or you might want to do splines to kind of blend it together a little bit better. And then I used a split line feature to basically create a new face. And then I deleted that face and replaced it with my own. So very common troubleshooting or diagnostic technique that I would use if I'm dealing with imported geometry or something where I don't have access to the feature manager trees. I can slice out a bad section of the model and then replace it with a patch. There's lots of ways to patch your model. Surface fill is just one of them. But excuse me. But if you're only going to learn one patch technique, surface fill is usually my go-to, just because if it doesn't work, it's only a 5-10 second investment and I can move on to something a little bit more intensive, like maybe a loft or a boundary. So with this filled surface, there's another item that I want to talk about. And I know I'm talking about filled surface a fair amount here. It's just a very useful tool. And there's settings in here that we should be aware of if you're going to be using it. So this is a similar example where I have a hole in my model, but now rather than a single surface, it's 4 separate surfaces that all form the edges of that hole. And what's important here is that the edges of that hole start and stop where the hole starts and stops. So you can see all these edges here. If I highlight them one at a time, they're all the perfect length for this hole. So if I go to my filled surface command and I try to do this again, then it works, no big deal. But there are situations where you cannot just throw your filled surface in like this. So if I go to my last fill example, here I have that same opening, or it looks the same, but at the top here, there's going to be a slight difference. So if I just take a look at this top section, you can see I have a much smoother cut now. And basically I have one continuous edge here instead of the 3 separate edges that I had before. So now when I look at this opening and I look at the 9 o'clock side, the edge is the right length. I look at the 6 o'clock side, the edge is the right length, edge is the right length. And if I go to the top, the edge is way too long. So to deal with this, there's a very simple option inside of SolidWorks, but as usual, you have no idea what it's going to do because it just says descriptively fix up boundary. So we click on that. What that'll do is it'll trim back your edges that are too long, or it can also extend edges that are too short. The ability to extend an edge that's too short is very limited. So if one of the edges here is just short of the corner by, let's say 10% of the edge length or 5% of the edge length, then fix up boundary might be able to jump that gap for me and bridge it, but it's not going to be as effective. Trimming it back is a lot simpler. It's almost like it's doing a power trim in the background. So it's looking at the edge and saying, okay, get rid of this extra section over here, get rid of this extra section over here, and then I'll be able to build my fill. If I don't have that turned on, and I try to make my fill and it says boundary is open, cannot be patched. So I have to use that fix up boundary option. And then it will basically generate as normal. So this is a little bit of a contrived example. I had to do a fair amount of work, as you can see from the tree here, to basically force that edge to be one continuous edge rather than the 3 separate edges I had before. But depending on the state you're receiving your model in, maybe it's already had a hole punch in it, you may need to keep an eye out for issues like this where the edge is too long for the opening, or if they're too short. If they're too short, I would rather just try to select another edge in there rather than jumping the gap using fix-it boundary. So it can technically do it. It's not going to work as often as it does for trimming back. Okay. And that's enough of fill. We can talk a little bit more now about some other surfacing. So sweep and loft. So just like in our normal solid features where we have a swept boss and base or a lofted boss and base, we have swept surface or a lofted surface. And for this, I'm going to show the sweep first. I have this little arch over here and a path that I made for it. And actually, I'm going to hide this second profile for now since we don't need it. So let's say I want to make a lofted surface. A swept surface, like I said I was going to do. Okay. So I select my profile, I select my path, and it behaves pretty much as you'd expect based off of the jump from extruded boss to extruded surface. So does it go from swept boss to swept surface. Where it gets a little bit more interesting is if I start putting in guide curves, and you may have already seen this or dealt with this before in a solid sweep, but another thing will happen here. If I try to add in a guide curve, so for instance, I have this guide curve on the side, and it's actually part of one. Come back here. It's part of
a bigger sketch, so I just need to turn my
selection manager and pick out just that single entity. Then as I add that guide curve, it's going to quite severely deform my surface as it moves through that corner, just because basically I'm now controlling the middle of my profile and the side of my profile, or the corner of my profile. And as it moves through here, because my path is in 3 dimensions, there's going to be a lot of twisting and deformation that happens. You can go into the options here, and this is going to be under profile twists. You can try and tweak these. Usually if it's this severe, tweaking these options, excuse me, tweaking these is not going to help very much. Right now it's on minimum twists. If I try to put this on follow path and first guide curve, you can see it's different, but it's not really better. Or if I put on natural, it somehow got even worse. So once you have something this severe, twists is not really going to help you. I usually try it anyways, because similar to the filled surface, if it doesn't work, I'm only down 10 seconds and I can move on to something else. So something I can do here is I can try to just add a second guide curve. So I can go back into this side. I'm going to add the other corner. And that'll basically just stop my arch from collapsing as it's dragged along that path for the sweep. So that will be able to stabilize it by quite a bit. And at this point, if I try to adjust my twists, you'll notice it doesn't really do very much here either. So very rarely does the profile twist make or break the model. It will just change it subtly, and depending on how close you are to your desired shape, that might be enough. But if it's egregiously wrong, it's usually not going to be able to fix it on its own. So I can basically make a sweep like that, and it'll create the surface for me, which I could use to join together my models in any way I want. Right. So all the same rules apply of surfacing, where I would use surfacing when I have some kind of complex geometry that I'm not able to create using my normal solid modeling tools. And if I get out of this sweep, the other option or other feature I want to show is just a lofted surface. So very similar to how a lofted solid would work. I can select my profile. Keep in mind that where you select the profile does matter. So if I select my first profile near the 3 o'clock side, I want to select my second profile near that same 3 o'clock side. And that way I'll be able to connect 3 o'clock to 3 o'clock. If I don't do that, and I click over on this other side, then it'll basically either not show a preview at all, meaning that the feature will fail, or it will just show a very twisted, deformed shape. So you can drag this back over, or you can just reselect the profile. But just something to keep in mind, the area you select the profile in does matter. And then I can also in here try to add in my guide curves, or with the loft, another option is to use a center line. And center lines versus guide curves, it's hard to kind of pinpoint, I want to use a center line for X and I want to use a guide curve for Y, but they do just give you slightly different effects. One of the big flaws of the center line, you can only have one center line. Guide curves, you can have multiple. But for the center line, if I specify path that I was using before for the sweep, it will use that and kind of gently guide my loft here as it goes from profile to profile. So this is going to be just a slightly different shape. I'm not going to stand up here and tell you guys loft is better than sweep or sweep is better than loft. They just give you different options. So depending on what you're working with, sometimes one will give better result than the other. So just something to kind of keep in your back pocket that if it isn't working, You can try switching over to loft. Loft
Loft
isn't
isn't working, try switching over sweep.
and there's kind of two
two
ways to accomplish the same task. If I can use that center line, I can also try putting in the guide curves here and see what kind of result that'll give me. With the loft tool, when I click on, this is actually interesting. The loft tool, if I try to click on the sketch here, it automatically launches Selection Manager for me. Whereas when I was in the sweep tool, I had to manually launch the Selection Manager. If you guys haven't done this before, the reason I have to do this is I basically made both of these guide curves here in the same sketch. So it's basically a sketch with two open contours. So if I just try to click on it inside of the sweep feature, SolidWorks is basically going to put its hands up and say, which of these lines you want to use for the guide curve. Rather than asking me that in a constructive way, it just freezes up and doesn't react at all. So that's when you have to use the selection manager. So that's in the right click menu here. Selection manager, if you have multiple contours in a sketch that you want to pick apart. So in this case here, I have two contours. One of them's for one guide curve, the other one's for the other guide curve. So in this case here, with the loft, it looks like using the path as the center line, then using the guide curve on just the inside, it gives me a much more gentle, stable transition as compared to that same combination of items in the sweep feature.
If it helps, Kenny, it's like the sweepy loft when you have the center line. Because if you use that center line as a guide curve, you'll see it pulls much harder. So that's how I tend to describe it, is it's kind of like a hybrid feature. It's loft following the sweep profile.
Yeah. Yes. So centerline kind of behaves like the path of a sweep. Technically, they're not the same thing. This is one of those things where I just tell you guys to try it. It's hard to come up with a rule of this one for this situation, this one for the other situation, but sometimes depending on your geometry, one will be very clearly better than the other.